Ladies and gentlemen, welcome back to another video. And in this video, we're going to be talking about weight and mass. Now, it's typical in the world today. People use the word weight in a synonymous way to mass, whereas the two are different. Weight and mass are two different things. So in this video, we're going to be talking about the differences between weight and mass, and you'll be shocked, but because believe it or not, these two are very different. Weight and mass are two entirely different things. Let's get into it. Okay, so we're going to first look at mass. The first thing we're going to look at is mass. So what is mass? Now, another name for mass physicists commonly use is inertia. So when I say mass, think inertia. The two are the same. Okay, so what is mass? I want you to picture a particle. Imagine a particle in your head. Say this is the particle. This is your head. You're looking at the particle. Eliminate gravity. Eliminate the earth. This is just a particle suspended in space. Now remember, if you watch my videos, my previous videos, in order for this particle to move, there has to be a force exerted on it. So this particle is not in the presence of gravity, it's not in the presence of the earth, it's not in contact with anything, so it's not going to move, it's just going to sit there suspended in space. Now, say I come and exert a force F1. What will happen to the particle? The particle will begin to move according to Newton's second law. What then happens? This is a timeline. I introduce the force F1 here. The particle begins to move. This force F1 is going to impart a certain velocity to this particle, and it will begin to move. If I then bring two particles, in order to move these particles with the same velocity I gave to this initial particle, I would need double the force. In other words, I would need a force of 2F1. Why is it so? Because the number of particles have increased in number. Double the particles require double the force. The more I add the particles, the more force I'll require. 3 particles will require thrice the force. Now, because we need twice the force to move 3 particles, the number of these particles is what is governing the amount of force that is required to push them. This is what we call mass. Mass is nothing more than a number. How many particles do we have? We've got 1, 2, 3. 3 is the mass. Mass is just a number. It is merely counting. So we've got 1, 2, and 3 particles. Let's call this particle a kilogram. That is the name of this particle. We'll give it the name kilogram. So how many kilograms do we have? This particle is similar to this particle, and this particle is similar to this particle. So consequently, this is similar to this. We've got 1, 2, and 3 kilograms. So we've got a mass of 3 kilograms. Again, what is mass? Mass is simply a number which comes from counting. If we call this a kilogram, like give it a name, literally give it a name, kilogram, then 1, 2, 3, we've got 3 kilograms here. So the mass is 3 kilograms. Mass is just a number indicating the number of particles we have. So we've got 1, 2, 3 particles, meaning we've got 3 kilograms, meaning the mass is 3. Now, weight is something completely different. Weight is a force. Remember, I say these are forces 1, 2, and 3. These are forces. Weight is something completely different. Mass is a measure of the number of particles we have. That's why you come across the definition. Mass is a measure of the quantity of matter. Why? Because mass is simply a way of measuring the number of particles that make up a certain body. But weight now, let me rub this. Weight is something else. Weight, like I said, weight is a force, but it's not an ordinary kind of force. Weight is a special kind of force. What kind of force is weight? Weight is that force a body experiences when it's in the presence of gravity. I'll repeat, weight is a special kind of force. Which force? The force a body experiences when it's in the presence of gravity. So say this is a particle sitting on the Earth's surface. We know that it's going to be experiencing gravity all around it. This gravity is going to be responsible for imparting a certain force on it. It is this force due to gravity that we are calling weight. I'll repeat, the force due to gravity on the body, on the mass, on the particle is what we are calling weight. So weight is nothing more than a force. Now let's come to this diagram. Say these three forces, 1, 2, 3, are forces due to gravity. Then the weight in this case would be 3Fi. Remember, F1. F1 is the force on one particle. So the forces on all these particles is 3F1. So if these forces were due to gravity, then this value would be the value of the weight. This would be the weight. So weight is nothing more than a force. Now I want to make the differences clear. Remember, we said mass is simply a number that indicates the number of particles that make up a body. So we've got 1, 2, 3. If we had 5 particles, we would have 1, 2, 3, 4, 5. And let's call the name of the particles, let's give them a different name this time. We'll call the name of particles, boxes, for example. Let's call the name boxes. So if we had 5 boxes, that would be the mass. I'll repeat, if we had 5 boxes, box being the name of the particles. Similar, like in a similar manner, in a similar way we call kilogram the name of the particle. We can simply call the name of the particle, we can simply give the name of the particle box. So that we have 1, 2, 3, 4, and 5 boxes. 5 boxes would be the mass. But with weight now, it's now a matter of dealing with force. What are we counting? We're counting the forces on each of the particles in question. So how many particles do we have? We've got 1, 2, 3. And each particle is experiencing a force of what? Of F1. So we've got 3F1. So the weight, I'll repeat, the weight, if these forces were due to gravity, the weight becomes 3F1. But, I want you to remember, but when it comes to weight, again, remember I said weight is a special force. Weight is a force a body experiences due to gravity, but there is another condition that has to be satisfied for us to call a force due to gravity weight. There has to be a support. In other words, the body has to be supported by a surface on the earth. Say this is a mountain. This is the surface of the earth. This is the surface of the earth. This is the mountain, however. When we've got a body here experiencing a force, the force it's experiencing while contacting the support, while contacting the surface, is called its weight. The same applies for a body on the mountain. While it's contacting the surface of the mountain, while it's contacting this very support, the force of gravity it will be experiencing here is also called weight. Now, obviously, because the force due to gravity varies with height, the weight here would be different from the weight here. And it's, if you delve in a bit, you'll find out W1, the weight here on top of the mountain, would be slightly less than W2, the weight here on the surface below the mountain. So these are the things you have to bear in mind. The special, the nitty-gritties, the little differences, okay, if you will, between weight and mass. So I'll repeat. Mass is nothing more than the counting of the number of particles that make up a body. It is a measure of the number of particles that make up a body. And then weight is a measure of the forces that are acting on those individual particles. The total number of forces that are acting on those particles, but not the total number alone, the total number multiplied by the force on each individual particle. So it is a total of the quantity of the forces that are acting on the particles that make up the body. That's weight. Now, I said it is common that you might come, when you're in the physics arena, people call inertia mass. They use the two words interchangeably. Inertia now is a measure of a body's reluctance to move when it was standing still, when it was still, when it was at rest. Or you could say it is a measure of a body's reluctance to stop when it was already moving. It may seem, due to the way they define inertia, as if mass and inertia are different. But if you really begin to look at it, inertia is proportional to mass to such an extent that we use mass as a measure of inertia. Mass and inertia become the same thing. And they are just the same thing. So do not be intimidated when you come across the word inertia. Inertia and mass are the same thing. However, mass and weight are two different things. Mass and inertia are two different things. Though they are used interchangeably in today's world, they are two different things. Always bearing that in mind. Thank you, ladies and gentlemen. Please leave a like, subscribe, and a comment if you enjoyed the video. Stay motivated.